Hello, thank you everybody for being interested in my proposal. I am Daniela Lanzado-Pazo, part of Artesia team, and I'm going to talk about a leakage detection system using decision trees. It's a proposal for the Battle Team Challenge 2020. Our proposal is based in two main underpinnings. So the different pressure values of any sensor have another layer of randomness due to consumption. By predicting the midnight pressure, by making the focus on the night, it allows us to reduce the randomness on consumption and to be able to detect leaks in a more reliable way. On top of that, we also perform neighbor comparison. So if we find a leak in a sensor, but not in its neighbors, we can infer that's maybe due to the randomness or maybe an inaccuracy of the decision trees. Whereas if we find that an area is affected, then we can guess in a more reliable way that's indeed a leakage. Our proposal is based in different sequential steps. The first step is the data normalization. So the initial data set is a very powerful data set since it contains a huge amount of information. It has 5 minutes samples. And that's very good because you can take a look at each single detail, but it has two added problems. First, it is not computationally feasible to perform predictions with such a big amount of data. On the other hand, it's a little bit more difficult to see the forest through the trees. If you see at each single detail so much, you cannot see the main trend if it's going up or down. So our solution is to extract the most meaningful features out of each single attribute. So we get the minimum and the maximum daily peaks. We also get the mean during morning, afternoon, evening, and night. The idea is to extract the most meaningful parts of the day and to be able to gather a little bit of information out of each. So we have performed some data normalization out of each value presented by the pressure sensor, the water level tank, and the water flow sensor too. So after we have performed some data normalization, we calculate the midnight pressure values. For making reliable predictions, we use cross-validation with 10 folds, and we perform predictions for each single pressure sensor iteratively. Finally, we perform the leakage detection. So we compare the results predicted by the decision trees in comparison with the real mean pressure values. If the tree is detected a lower pressure than what it should be, then we can guess more or less that's a leakage. So as a final result, the decision trees has a very robust prediction with only 0.02 of relative error rate. Are the breakdown results for each water level sensor, where pressure sensor, where the blue line is the residual error, whereas the red is the percentage. So we can see that it has some randomness. It is more accurate in some pressure sensor than in some others. It's also worth to mention that the class attribute has been included in the train set, not in the test set, but in the train set, and hence the results might be better than what it actually looks like. But by including the class attribute, it has proven to be more reliable performing leakage detection, which is at the end of the day our main goal. As a result of that, our leakage detection system was able to detect 109 different leakage in 30 different pressure sensors. We see that we have a bigger number of leakage in some pressure sensors than in some others, which is something normal to happen. So as a final conclusion, we can infer that it is possible to perform an approach using data science and decision trees and to target the mean pressure values in order to be able to predict leakages reliably. So thank you everybody for watching.